in this next example in section 10.2, we're going to combine the ideas of our laws of exponents that we've talked about in the past and our rational exponents to kind of simplify some problems using both ideas. Remember the rules for exponents when I'm adding or subtracting, multiplying, raising to a power, or dividing? Do you remember the silly saying, all night my aunt ran mail downstairs? Well, it helps us remember the different rules anytime we have exponents. When we're adding and subtracting, what do we do with the exponents? Nothing, right? We just combine like terms. They have to have the same variable with the same exponent in order to be able to add or subtract those like terms. When we multiply, as long as the bases are the same, when we multiply, we can really add the exponents. When we raise to a power, we multiply, and when we divide, remember, we subtract the exponents, as long as our bases are the same. Let's use those ideas and our rational exponents to simplify. Look at example 6 with me. Use the laws of exponents to simplify. A says we have 3 to the 1/5 times 3 to the 3/5. You notice that our bases are the same, they're both 3's, and we're multiplying. So as soon as we multiply, I know that I can take those like bases, combine them together by adding their exponents. I have a 1/5 plus a 3/5. They're fractions, and I'm adding, so I need to make sure that I have a common denominator. Well, I already have a common denominator here, so that's kind of nice. So what is 1/5 plus 3/5? Well, I can say really then that I have 3 to the 4/5. You could try to convert this into radical and see if that'll help you simplify even more. But 3 to the 4th power and then the 5th root of 3 to the 4th power doesn't simplify anymore. You notice that I have 4 3's that can't be broken down anymore. That's not enough to give me a group of 5. So my final answer would just be 3 to the 4/5 power. I have positive exponents. I can't be simplified anymore. That would be my final answer. What about B? I have a to the 1/4 divided by a to the 1/2. You notice that my bases are the same and I'm dividing. I should be able to combine them then with the same base by subtracting the exponents. So really I have the problem a to the 1/4 minus 1/2. Now I have fractions and I'm adding or subtracting, so I need a common denominator. It looks like my common denominator here would be 4, so I'm going to multiply the second fraction, the numerator and the denominator, by 2 so I can get a common denominator. That leaves me with the problem a to the 1/4 minus 2/4. 1/4 minus 2/4 is really a to the negative 1/4. Ew, though, he has a negative exponent, right? And we always try to have positive exponents if possible, because negative exponents don't make much sense. So a to the negative 1/4 power, if I want to make it positive, needs to drop down, and so my final answer would be 1 over a to the 1/4 power. All right, let's look at these two. C says 7.2 to the 2/3 power raised to the 3/4 power. I know it looks kind of confusing because you got decimals and fractions and a whole bunch of exponents in there. But really, we just have a base that's to the 2/3 power raised to the 3/4 power. Don't let it confuse you that it's a decimal. So if I gave you this problem and the base was an x, do you remember when we raise to a power what our rule is? Well, when we raise to a power, we really just multiply the exponents, right? So I can do that. Let's keep our base, the 7.2, and let's multiply our exponents. Remember, when we multiply, we don't need common denominators, only when we're adding or subtracting. So I end up getting 7.2 raised to the 6/12 power. Now, can't 6 over 12 be reduced? And so I can really say that I have 7 to the 1/2 power, or I could say the square root of 7.2. Either way is acceptable. I have positive exponents. I can't simplify anymore. Now, if they ask me to kind of convert it even farther and simplify it into a decimal and round, then I can use my calculator and do the square root of 7.2. But let's go ahead and leave it with our rational exponents, as long as I have simplified, reduced, and I have positive exponents. All right, last one here. I have a to the negative 1/3, b to the 2/5. All of that is raised to the 1/2 power. So what I really want to do is I want to take this 1/2 and I want to distribute it to this base and this base. Now remember, when I take a to the negative 1/3 and I raise it to a power, I'm really multiplying the exponents. So I'm going to go ahead and go through and distribute or multiply my exponents through. That gives me a to the negative 1/6 and b to the 2/10. Ooh, I don't like the negative exponent, so let's go ahead and make it positive. And let's go ahead and reduce this exponent. So my final answer is b to the 1/5 over a to the 1/6. They're not like bases. One's a b and one's an a, so I can't combine them. This is simplified, positive exponents. It looks like this is my final answer on that one. Make sure that you remember your rules for exponents so that you can simplify all different types of exponential problems, even ones with fractional exponents.